Hey everyone, this is Rob with Codecademy. I'm a software developer based out of Seattle, Washington. In this video, we're going to walk through the R project, calculating population change over time with R. So far, we've learned that R is a powerful statistical programming language with a large community of data enthusiasts. To complete this project, you'll need to be familiar with how to calculate arithmetic with R and understand the normal order of operations, how to store information inside of variables, and also how to call a function in R and pass in arguments. Alright, let's get started with our project. In this project scenario, you work at the UN in the Urban Planning Department and you're interested in tracking population growth across major metropolitan regions. And we're hoping that by looking at historical population numbers that we can predict future growth. So we're going to use what we've learned about the basics of R to calculate the population growth of Istanbul, or as pronounced, Istanbul. We're going to take that population growth and create a short report. Alright, at the top of our notebook, we can see that there's already a function created called calculate annual growth. Through the course of this project, we're actually going to recreate this function on our own. Then, in our last step, we'll come back and take a look at this function to see if we get the same results. So let's start with step number 1. In step number 1, we're going to take a look at the explosive growth of Istanbul. It's one of the world's 10 fastest growing metropolitan areas. This program that we're writing can be used for data with any city, but we'll start with data from Istanbul and save it to variables. Using those variables will allow us to swap out the data in the future. So in step 1, we have the following chart with an abbreviated list of the population size by year in Istanbul. So go ahead and take a moment and read over the data. We can see we have a column of year, populated with data from 1927 to 2017, and then we also have a column of population, where every year, such as 1927, has a corresponding value of a population of 691,000 people, ending with the year value of 2017 with a corresponding population value of 15,029,231. That's some explosive growth. So let's go ahead and mark step 1 as complete, and we'll go ahead and jump into step 2. We're going to begin on line 13 by creating a variable named city name, and we're going to give it a value of the string Istanbul, comma, Turkey. Alright, that was straightforward enough where we just named our variable, and then we used the caret and the dash to assign to it the string Istanbul, Turkey. Now, I always like to check and make sure that my code is working as expected, especially when starting something new. So I'm going to use the print method, and I'm going to pass in the variable city name. So I'm going to save my code, and we're able to print out successfully Istanbul, Turkey. Awesome. I'm going to go ahead and remove line 14, and mark step 2 as complete. And we'll move on to step 3. So, in step 3, we're simply going to capture the population data from 1927. So we'll create a variable pop year 1, and we're going to set it equal to the value of the year 1927. So we'll go back to our chart, and we can see that the population in 1927 was 691,000. So let's go ahead and add that value here. Alright, we can mark step 3 as complete. If you'd like, you could go ahead and just do a quick print of pop year 1. And we can see that we're getting that 691,000 number that we would expect. So we'll move on to step 4, and I'll go ahead and move this print statement down. In a moment, we'll populate it with our new variable. For step 4, we want to capture the population of the year 2017. So we'll create a variable pop year 2, and we'll set it equal to our population in the year 2017, which we can see is this gigantic number of 15,029,231. And now to do a quick check, we're simply going to print our variable pop year 2. Perfect, just as we would expect. So let's mark step 4 as complete, and we'll move on to step 5. In this step, we'll begin using variables to perform calculations. We're going to write a script that allows us to calculate the annual percentage growth. Now remember, annual percentage growth means what is the percentage of growth per year. Now, currently, if we look at our chart, we don't have yearly recordings of what the population is. So we're going to have to approach this another way. In step 5, we're going to begin by getting the population change from the year 1927 to the year 2017. So we'll do that by declaring our variable pop underscore change, and we're going to set it equal to the value of pop year 2, which is our greater number, and we're going to subtract pop year 1. So now let's go ahead and print those results and make sure that they are what we would expect. We'll print pop change, and we get 14,300,000 plus. And if we do the math in our head, from pop year 2, 15 million plus, minus almost 700,000, that makes our result seem logical, and so we know that we're on the right track. So let's mark step 5 as complete, and we'll go ahead and move on to step 6. So in step 6, before we calculate the annual percentage of growth, which is the year-over-year growth, we have to calculate the percentage growth rate for the 2 years that were provided. So we're given the formula in step 6. We'll declare a variable, percentage underscore GR, and this is just a variable name that I'm choosing that I think is descriptive of the value that we're containing. So we're going to find the percentage growth over the 90 years, from 1927 to 2017. And remember, this percentage growth isn't going to be the annual growth year over year, but the percentage growth covering that 90-year span. So to do that, we're going to take our pop underscore change, which we know is a little over 14 million, and we're going to divide that by our pop year 1, which we know is around 700,000. And then we're going to multiply that by 100. So let's go ahead and print our percentage growth. And the result is over 2,000% growth over those 90 years. So let's mark step 6 as complete, and now we want to look at annual growth. What is our percentage of growth year over year? So we'll start with creating a variable, annual growth, and we'll set it equal to our percentage growth, which is over 2,000%, and then we divide it by the difference of the years 2017 minus 1927, which in your heads, if you do the math, is 90 years. So we'll mark step 7 as complete, and then for step 8, we simply want to print annual growth. And when we do, we see that we get a result of 23.05553. So an annual growth of 23% for 90 years takes a population from around 700,000 to over 15 million. So let's mark step 8 as complete and move on to step 9. We're going to go ahead and try to use the same formula, but changing the value of years. So we might wonder, was there just an explosion of growth early in the 1900s or in the mid-1900s or once we hit the year 2000? So if we go back to our original table, let's just take one example. Let's look at the annual growth between the year 2000 and the year 2017. That's the latest 17-year period. So we'll change pop year 1 growth to 8,831,800, and then we'll need to change our value in our annual growth variable to still be the year 2017, but now instead of 1927, we'll look at the year 2000. In our head, we can see that this change is somewhere around 7 million over a 17-year period. So let's save our code and see what the results are. In this example, we can see that in the past 17 years, the percentage growth has been around 4%. As someone looking at the future of Istanbul, it's probably really important to know that your city isn't growing at 23% for the past 2 decades, but something closer to 4% as you plan your city's future. So feel free to take some time and look at this table and input some different years for the pop year 1 and the pop year 2 value and evaluate what the annual growth has been for the city of Istanbul to get a better feel for how to use this data. Alright, let's go ahead and mark step 9 as complete. Finally, we'll look at step 10. We've coded this calculation from scratch. However, at the top of our notebook, we've already included a function named calculate annual growth. As I mentioned before, this does the same work that you just coded. So with our new knowledge of calling functions and our understanding of variables and arguments, we're going to call the function to get the same results. So I'm going to go ahead and comment out line 24. And on a new line, I'm going to call our function calculate annual growth, and this is going to take 5 arguments. Year 1, which is 1927, year 2, which is the year 2017, then our population for year 1, which we can refer back to our chart, is 691,000, then our pop for year 2, which is 15,029,231, and then finally our last argument is going to be the city, Istanbul, Turkey. Okay, let's go ahead and run our code. And the result of calling our function is we have outputted to the screen a sentence to give us some more context that says from 1927 to 2017, the population of Istanbul, Turkey, grew by approximately 23% each year. Alright, great job. And again, you can return back to this table, and you can pass in the values from any of these years into this calculate annual growth function that's already been pre-populated for you. Alright, great job working on this first project with R. As you've seen, R is a popular programming language used by data scientists and researchers. And you've already seen with just a very introductory knowledge of R how you can take data and apply it to the real world. If you're working with data, then R is a fantastic language to learn. Alright, this is Rob with Codecademy. Happy coding.